Hey mathematicians, so far we have found rate of change from a table, and today I'm going to show you how to find rate of change and another aspect of the situation from an equation instead. And there will be more formats of linear equations coming in the future, but for right now we are going to start with one that you're going to hear a lot about, y equals mx plus b. So we know from previous lessons that x is used to represent your independent variable in a situation, and y is used to represent your dependent variable. But two new components are your rate of change and your initial value, which are represented here in this equation. So allow me to demonstrate how we would turn this situation into an equation. So in this situation, it says that we can rent a bike for a flat fee of $20 and an additional $2 an hour. Now we know that that hour is going to be your independent variable because the only other thing that's being measured in the situation is dollars. And we know from previous activities that most of the time your unit of time is going to be your independent variable. And since it is specifically saying that the price of the bike will increase $2 an hour, that means that the amount of money you owe will increase by $2 for every hour that you have it, right? So part of the equation is going to be y equals 2 times x. And the reason for that is because for every hour, which is being represented by x, that you rent the bicycle, the price of the rental overall is going to go up. The other component is this flat fee. And a flat fee, for those of you guys that don't know, it's just a fee that they charge you literally just for showing up to pick up the bicycle. It doesn't matter how long you keep the bike, you're paying that 20 bucks regardless. So that is going to become your initial amount because no matter what, you have to pay $20. So the equation that would represent this situation is y equals 2 times x because it increases $2 for every hour plus the original $20 that you started with. So in this case, 2 is your rate of change and 20 is the initial value in this equation. In example number 2, this time our independent variable is going to be measured in hours because the other variable that is being measured is inches. And once again, our unit of time is going to typically be our independent variable. So apparently the candle is burning at a rate of 1 inch per hour. So what happens when a candle burns? It decreases in height, right? So that means that the rate of change is not just going to be 1/2, it's going to be a negative 1/2. And it's 1/2 times x because it's negative half, it goes down, it decreases 1/2 of an inch for every hour. And then we also need the initial amount. Well, how much did the candle start out at? The candle started out at 6 inches. So that's the initial value. So the equation for this situation is y equals negative 1/2 x plus 6. So what kind of problems am I going to ask you to do with this new knowledge that you have? Well, one thing I'm going to ask you is, what is the rate of change? So in the example I've given you here, the rate of change is going to be that 5, because that is the number that is sitting in front of the x. So the rate of change for this given equation is going to be a 5. Then the next question it asks me for is, what is the initial value? So the initial value is going to be 3. Now, we haven't really talked a whole lot about this yet. And so while the initial value is going to be 3, this particular activity that we're doing asks for you to write it as an ordered pair. So let's say, for example, you were going to graph this equation. The initial value would be right here at 3. So because the directions say to write it as an ordered pair, the way we're going to write it is 0 and 3. So even though the rate of change, even though the initial value is 3, because it's asking for it as an ordered pair, we would write it as 0, 3. And then last but not least, is this increasing, decreasing, horizontal, or a vertical line? Well, since the rate of change is positive, so that's a positive 5, that means it's going to be increasing. So this would be an example of the type of problem you would be expected to do. You would be able to look at the equation and identify the rate of change, the initial amount, and whether it's increasing or decreasing. All right, so here's a couple more examples really quickly. What I would strongly suggest you do is pause the video and try to identify for each of these the rate of change and the initial value for each of these two provided equations. I'm going to assume you did what I asked you to do and that you paused the video and you're ready to check. So for the first equation, the rate of change is going to be that -3 that is sitting in front of the x, and the initial value is going to be that +5 that is out there to the side. In example number 2, the rate of change, I keep hitting that pen, I'm sorry, instead of the highlighter. The rate of change is going to be +1/2, and the initial value is going to be a +2. So on the assignment that involves the Google Sheet, if I ask you to write the initial value as an ordered pair, this is what you would do. You would just say, for this one, you'd say 0, 5, and for this one, you would say 0, 2. Because if we were going to actually make a graph of it, this first one would be up at like 0, 5, and then it would go, and then this other one would be at like 0, 2. Oh, oops. That first graph is decreasing, isn't it? So it would actually start off there, and then it would decrease. And then in the second example, it would start right here at 0, 2. And then from there, it would increase.